The scientific method is an important part of any scientific process. And whether you know it or not, you actually probably use parts of the scientific method on a daily basis when you try to solve a problem. What's great about the scientific method is it's this cyclic pathway that helps us to continually work on a problem and refine a problem by continuing to make observations and question those observations. And so the initial observation might be something as simple as you go into the room and you go to turn on the light and the light doesn't turn on. That's where we're going to start, right? That's your observation. You observe, I flipped the switch up, the light did not turn on. So if we were to approach this problem using the scientific method, right, the next thing and the obvious thing would be, well, why did the light not turn on? So what are some questions, right, that you could think of that would help you understand why that light didn't turn on? Maybe the bulb broke, right? Maybe the bulb is broken. Or maybe the electricity is out. Maybe there was a large storm and the power is out to your house or to the neighborhood. Or maybe the light switch itself is broken, right? Those are all excellent questions that we would have to ask ourselves, right, when we walk into a room and turn on a light and the light didn't turn on. Now to solve the problem, we have to be able to test those questions. So, okay, the light bulb is out. Maybe the light bulb is broken. I'll go test the electricity in another room. I'll go walk into the room next door, turn on the light. Does the light turn on? Yes or no? And that's going to help you refine, right, your ideas about why maybe the light is not working. So we can test the electricity in another room. We could test the circuit, right? If we had an amp meter, we could test the circuit to make sure the circuit's carrying electricity, or we could even switch out the light bulb to see, is the light bulb broken or is the electricity in that room or your house or your neighborhood? Those are all ways that we could test those initial questions of why didn't the light turn on? Now, each of those questions we ask to test this process, right, we're going to run those experiments and observe, right, the results, and then use that to improve our hypothesis and change our hypothesis. So for example, you go into the room next door and you turn the light on. Does it work? Yes or no? If the light in the room next door works, then probably the light in your room should work as well. Maybe it's the bulb that blew. Or you take the amp meter and measure the circuit, and is it conducting, carrying a load? If that answer is yes, then okay, you probably have electricity in the room. Another reason that maybe that bulb is broken. So finally, let's just get up on a ladder and replace that bulb. Now, yes, I get up on the ladder, I replace the bulb, flip the switch again. Does the light turn on? Yes or no? Each of those are going to provide data that you can use to refine why you know or why you think the light's not working. And we can use that information to help us develop a general theory of maybe why that light is out. And based on that information, we can repeat this as needed. And this is an important part of the scientific method, is that we can repeat this process over and over and over again based on our data that we collect, right? Based on the data that we collect, we can look at that data and use that to develop a better understanding of the problem and maybe ask ourselves some more questions and keep worrying, okay, how, with my new set of questions, how would I test those questions? Okay, here's the results from that. Okay, now I've got one more round to refine my hypothesis. So in this simple case, we can get away with probably just one series of questions and testing, but in a more complicated case, you might be working your way around in the scientific method for several iterations of this to actually come to a solution or an answer that explains your observation. Right, and so here's just kind of a linear layout of what we just worked through in the scientific method based on our initial observation that the bulb didn't turn on. Some initial questions, maybe the light bulb is broken, maybe the power is out, maybe the switch is bad. And each of those will have a hypothesis that, right, the light didn't turn on because the bulb was blown. Well, how would I test that? I would test that by replacing the bulb and checking that again. And the data you would collect, did the new light bulb work or did the light still not turn on? So each of these tracks will give us a different hypothesis. We have a few different tests for that hypothesis, and we'd expect different data from that. But we can all use that data collected to help get a better understanding of the problem and maybe further refine our hypothesis and our plan of attack.